Okay, let's take a look at a couple of practice problems for the wave speed equation. We're going to start as we always do by highlighting what we know and then solving for what we don't know. So it says, what is the velocity of a wave with a frequency of 760 hertz? I'm going to highlight that. And a wavelength of 0.45 meters. The thing that we are looking for is the velocity in this case. So our equation is v, which is velocity or speed. You'll see them interchanged in this particular case, equals lambda times frequency. Lambda is our wavelength, which is 0.45 meters. Our frequency is 760 hertz. If I plug all of these in, and then multiply, you end up getting 342 meters per second as your velocity or speed. Now, let's look at a problem where we are looking for something else. So in this case, it says a wave has a wavelength of 125 meters and is moving at a speed of 20 meters per second. What is the frequency? So we're going to start with the same equation. Velocity equals lambda f. But then we're going to rearrange it. So I am looking for frequency, so I want to get frequency by itself. So I'm going to divide both sides by lambda. And I get that frequency is equal to the velocity divided by lambda. Now I'm going to plug in my numbers. I know that my wavelength is 125 meters, and my velocity is 20 meters per second. So I'm going to say 20 meters per second divided by 125 meters. Anytime you are solving for something other than velocity or speed, your speed goes on the top and is divided by the other thing that you have. So when we plug this into our equation, we get 0.16 hertz as our frequency. Remember that a hertz is just a 1/2, so that's how we cancel out. When we have meters over meters, we're left with divided by seconds. That's a hertz.